But in the assignment that we graded yesterday, there was one town that started off with 7,200 as its population. And it was growing at 100 people per year. Do you remember that problem? The other town had 8,850 people in the population, and it was losing 50 people a year. Your job was to find out how many years it took until the two towns had the same population. Now, graphing this, think about it. If we were to graph this, that means my y-intercepts would have to be 8,850 and 7,200. And I would be going up 100 and over 1 and down 50 and over 1. And first of all, with those kind of numbers as a y-intercept, that's really hard to graph. The second thing about it is with those kind of numbers, when we do graph it, it's really easy to make a mistake to try to find where they intersect at, right? So there has to be another method to get the exact answer and not just a guesstimate. And that's what we're doing today. We're using the substitution method to solve this. So let's, I'm going to ignore that's there. We're going to use the substitution method. Eventually, after your quiz next week, I'm going to teach you one more method. It's called the elimination method, my personal favorite. I like to solve by elimination, but I'm going to tell you that each one of these methods, the graphing, substitution, and elimination, it depends on the order that the equation is in, will determine which one is the easiest method to solve it. Okay, so sometimes it's easier to solve the elimination method. That's if x's and y's are all on the same side. Okay, so you're going to have to try to like get comfortable with deciding which method to use, but you don't know that one yet. Substitution says that I have this. It's equal. Remember my teeter-totter? So y is equal to 7,200 plus 100x. My teeter-totter is perfectly balanced right now, and I have to maintain that balance. I know that if I go over here to y, I can plug in anything that is equivalent to y, and I will still maintain that balance. All right, now think, this might be dating me a little bit, but hopefully it's a classic and you guys remember. Do you remember the Indiana Jones? Did anybody see Indiana Jones movies?
No, but
Yeah.
Okay, well, there's one where there's this, this artifact that's sitting on this pillar. And he has a bag of sand. And he goes over there to the artifact, and he pulls the artifact off at the same time as he replaces the sand with it. Now the sand had to be exactly the same weight, or the whole temple crumbles and then he gets trapped in the rubble and dies. Well, he didn't, but he apparently did not have the right weight in it because the temple crumbled and he was chased by it, the rolling ball, and you know, all kinds of crazy things happened. Of course, he survived. It's all good. But that is what we're doing here. We're making a quick change to maintain that equilibrium on the teeter-totter. Okay? As long as it's a balanced or equal weight, we can do that. We have this equation on our teeter-totter. From the other equation, what can we replace the y with that's still the same weight? What is equal to y that we can replace it with? See that right there? that is equal to y.
Oh. Okay, yeah.
So we're going to pull y off the pillar and do a quick change and put 8,850 minus 50x where it was. And the whole reason we want to do that is because now our equation has just x's in it and we can solve using our skills of solving equations. Does that make sense?
Yeah.
That's exactly what we're doing. We're changing out something that's equal to something else so that we can solve it because we're turning it into an equation with just one type of variable instead of both x's and y's. Okay, now I could go ahead and solve this out this way, but I'm not going to take the time to do it. But, well, maybe I will just, we'd add 50 to both sides, which would give us 150x over here. We'd subtract 7,200 from both sides, which would give us 1,650 over here. Take 1,650 divided by 150, and that's our answer. And that's our exact answer. That's not the, I think it's in the right location on my graph answer. Okay. So this is the whole reason why we're doing it a different method is because we want to get the exact answer every time. And sometimes with those huge numbers, it's just not logical to try to graph it. Okay. So now we're going to go over here. This is where we're going to start working on our notes. Okay. So we're on the notes that say 6-2B, 6-2B, and we're on example 1. We have equation 1 and we have equation 2. Equation 1 is solved for y. It says y equals 2x plus 2. And equation 2 says y equals negative 3x plus 4. If I put, doesn't matter which one I put, I can put y equals 2x plus 2 up here. So I use my first one, it's right there. But I want to make a quick change because I've got an x and a y in it. I can't solve anything out when I got both variables. So I want to do a change.
Put the second one.
We're gonna put negative 3x plus 4 and do a quick change with y. So now I have negative 3x plus 4 equals 2x plus 2. Did you want to do notes on this?
I don't have them with me, but I think they're still online.
Okay, so we want to get the x's on the same side, and we want to get the constants on the other side. So what should I move where? All right, let's move the 3x over here because then I can add it. We like positives. That goes away. That was what we wanted it to do. Over here we have 5x plus 2. Okay, now what do I do? Subtract 2. Yep, and unfortunately we get x equals 2/5. It's a fraction. It's all good. We can deal with it. Trust me, when I first saw it, I'm like, oh, really, man? Why did I choose that one? I want whole numbers. Yes. You could. Yeah. All right, so we found x, but we still have to find y. We could plug it into either the first equation or the second equation, really doesn't matter. But I know that my x is 2/5. So I might do this one just because it's easier and there's room on top. So I do 2, and then I'm going to replace the x with 2/5 plus 2. Now, good thing we have calculators these days, right? All right, so that's 2 times 2 is 4. 1 times 5 is 5. So I have 4/5 plus 2. So what is y? Yep, y equals 2 4/5. Yes,
But wouldn't you want it to be in y equals mx plus
we're not graphing.
b?
This whole method that we're learning is going to be in place of graphing. So we don't have to graph it.
So it's just giving us a place where it intersects.
Yep, that's the place where it intersects. That's the point where they meet without actually having to graph it to find the point where they meet. All right, so let's move over here to example 2. Any questions at home? You guys are super quiet. Is it making more sense the second day around? I hope so. Okay. So this one's a little different because they're not set in the y equals format. One of them is. The other one is in a different format. So what we're going to do is we're going to take this bottom one, and that's the one we're going to set up in the teeter-totter. So we have 4x plus 2y over on this side, and that equals 12. The first equation is solve for y. So that's my artifact on the pillar, right? I'm going to go over here on this side of my equation and I'm going to rewrite it, but this time I'm going to pull that y off the pillar. What's going to go in its place? What's equal to y?
2x.
That goes in the parentheses.
This looks different than before. Yeah. Well, because that equation is. I know.
Mhm. Okay, you know what? It looks different, but we're still doing the exact same method. We're just replacing that variable with what it's equal to. It's just in a different location. But we're still doing the quick change Indiana Jones mode, okay? All right, so now,
So is that like a rule that we have to follow? So if it's not in y equals mx plus b, we have to put it in parentheses. Instead of on.
yeah, you always want to put it, yeah, because you're gonna want to distribute that through. That outside number, see how there's a coefficient there, right here, in front of, it was like 2y. Well, when you have multiple parts to y, then you have to distribute that 2 through both parts. So that's why I put it in parentheses, so I would know that it's not just, if I didn't, let's say it didn't, and I put it right next to it, what does it look like?
It looks like.
It looks like 22x, and it's not 22x. It's supposed to be multiplying. Okay. All right, so we want to solve for x. So how do I solve for x in this problem?
You multiply 4x plus 2 times 2x minus 1. No, 2, that was x minus 1.
Yeah, we're going to set the 4x aside right now, and we're going to distribute the 2 through both of those pieces. So we get 4x here, and we get minus 2 here.
And then you can just add the 4x's together.
add the like terms, so these guys get together. Add
And now
2,
We can plus 2,
we get
and
8,
then we're gonna be able to divide by 8.
correct. So we get x equals 7/4. Another yucky one. Now I'm not done yet. I just have my x. I still have to find y.
Your wife.
But I have a choice. I can put it in the first equation or the second equation. One of those is way easier to solve for than the other one. The y equals 2x minus 1 is way easier to do. So we're going to take 2 times 7/4 minus 1.
We're turning the 2 into a fraction. We get
14/4, which is 7/2, right? 7/2 minus 1.
And you get 5/2.
5/2, which is 2.5.
How?
Because 7 minus 2 is 5. And then you still have a numerator and denominator.
Or-
So 5/2 is 2.
Or think of it this way. What's 7/2 as a mixed number?
Um,
2 goes into 7 how many times?
So you see that this is more like
3.5. 3.5 minus 1.
Okay, yeah.
Okay, so,
And then how would you write that? You just have your x and your y.
yep, you just have your x, you have your y, and you're good. I'm going to tell you that there may be a couple of fractions on your worksheet I'm giving you today, but the majority of them are going to be whole numbers. Okay, so you don't have to worry about that as much. Yes.
So we have today's worksheet and yesterday's.
Mhm. All right, now we're going to skip 3 for now. We're going to go to 4 first. All right, this looks like another one of example 2. We have y equal to 2x minus 4. So that's going to be our quick change. So this is our teeter-totter problem. We're going to take and remove the y. And we're going to put 2x minus 4 in its place. Now, you guys, I know I shouldn't have done this, but all of my examples are where we're replacing the y's. But sometimes the x is being replaced. Don't let that throw you, because either way, you're trying to replace one or the other just so you have an equation that has just one of those variables in it. Okay, so you can replace the x's. All right, now we're going to distribute. And this one, something interesting happens.
Oh,
The
they're both
x's
like
cancel out.
terms.
The negative 6x plus 6x
Equals 0.
cancels out. We don't have any x's anymore. So we got rid of the y's, and now we got rid of the x's too. So we're left with negative 12 equals negative 12. If we were to graph these two equations on the same coordinate plane,
They expand out.
it would be the same line, which means there are an infinite number of solutions. It's just an 8 sideways. Now, you guys, the reason why I know it's the same line and it's infinite is because -12 actually equals -12. If our variables had canceled out and we would have been left with -12 equals 7, is that true? No, this would have been a no solution or parallel lines if you were to graph them. So if the variables cancel out and it leaves you with unequal sides, that's a no solution.
So if there was like -12 and 12. That would be no solution.
Right. Okay. So that's one of the special cases. All right, now we're going to go to example 3 now. I told you we were saving that for towards the end.
Yeah, the y is just weird.
We have a y and an x in the first equation. We have an x and a y in the second equation, but none of them are solved for. We don't have a y equals or an x equals. So that means we have to solve for one of those variables. Now we have 4 choices. Don't you love choices? We can solve for the first y, the first x, the bottom x, or the bottom y. And I'm going to tell you, one of those is easier than the other 3.
The one without a number.
The one without a coefficient. We want to solve for this y. And the reason is, if we solve for any of those others, we're going to have to divide by that number and we're going to get fractions or decimals. And you know what? I'm going to avoid fractions and decimals at all, if at all possible. So I'm going to solve this problem for this y. So I'm going to rewrite this. I'm going to karate chop and I want to get y by itself. So how would I do that? Plus 6x. In a way, yeah. All right, now I have y equals. That was the second equation. I solved the second equation. So I'm going to cross that one off because I'm going to use the new and improved version. Now I go to the first equation because I haven't done anything with that yet. That's the one that I'm going to replace the y with.
Does it matter if the -7 is in front of the
Nope,
6x?
not at all. So I'm going to put my -7 plus 6x. And now I'm going to distribute that through. So that's -21 plus 18x plus 2x equals 4. Any like terms I can put together?
The 2x and 18x.
Okay, that gives me 20x. Now I want to get this over to the other side. Which gives me 25. Again, not a nice number. X equals 5/4. Okay, now I still have to go back and plug it in somewhere for my y. Guess what the easiest place is? This one right here. So I take -7 plus 6 times 5/4. That's -7 plus 30/4. What's 30/4?
6.
Like 5.
5.
Come on.
No.
2 goes into both. How many times?
Twice.
Okay, so 15/2. What's 15/2 as a mixed number, Jaden? 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 All right, Gage. Tell me, what's 15 over 2?
7.5.
7.5. So I have -7 plus 7.5. So what is y? Yeah, you guys, sorry, you're not seeing it. There. It is, it is. You should see what pre-calc has to do for -7 plus 7.5. 1/2. All right, so you guys. I'm going to tell you it's a little bit easier for your problems because most of them are whole numbers. Okay, so at least you don't have to deal with the fraction part of it. We're going to do one more problem and it's a word problem. Yay, word problems.
No.
A store. Gage, you don't like word problems? Come on. All right, a store sold a total of 125 car stereo systems and speakers in 1 week. The stereo systems sold for $104.95 and the speakers sold for $18.95. The sales from these two items totaled $6,926.75. How many of each were sold? So we need to find out how many of each of these, the stereo systems and the speakers, were sold. So first of all, we're going to define our variables.
Couldn't you just divide both of them by 100?
Nope. Much more difficult than that. So X is the number of stereos. And Y will be the number of speakers. All right, now we have a total of 125 of both together. So that equation looks like this. Does that make sense where that came from? X plus Y equals 125?
Could you actually like walk us through how you picked out which?
The variables? You could have put Y as stereos and X as speakers. It's all good. Doesn't matter which one's which. We just knew at the end it says how many of each were sold. So that's telling me I've got the two things are my variables because that's what I need to find. All right. I know that there was a total of 125. Now we're going to have a money equation. Ready? So this was the number of items equation. And now we're going to have a money equation. How much was the stereos? 104.95. And we sold X of them. So that's how much money came in from the sale of the stereos. How much money came in from the sale of the speakers?
$18.
Not just once though. Y times, right? And how much money total came in?
696.
Oh, wow, $6,926.75.
So that's my money equation.
Whoa. What does that say?
$6,926.75. How am I going to solve for X and Y?
Put X plus Y equals 125.
Remember, I can't do a Indiana Jones move until I get one of the variables solved. So do I want to solve for this X, this Y, this X, or this Y?
The one without the, whatever you call it.
Coefficient.
Yeah.
So we can solve it for X or Y, doesn't matter. What do you want to solve for?
Y.
Y? Sure.
X.
Not why. We haven't solved for X yet.
So let's solve for X just because it's new. Okay, so we're gonna throw the Y over by subtracting. So we have X equals 125 minus Y. We can get rid of this one. We're not using that one anymore because we got the new improved version. Okay, so now we're going to replace the X in the other equation with our new value of X, which is 125 minus Y. Everything else stays the same. Now we can distribute. Ew. See, this one would have been a really bad one to graph. Do you think? 104.95 times 125. Wow, that's 13,118.75 minus 104.95Y plus 18.95Y equals 6,926.75. It's a big one. These two are like terms, so let's put those together. So I've got negative 104.95 plus 18.95, and that gives me negative 86Y. You guys are so quiet at home.
Yep.
I can always count on you, Gage. Okay, where to go? There we go. Okay. Evan is in a different class now. Second hour, I believe. Oh, okay. All right. So what are we? I keep losing it.
Oh, it's, no.
I have a feeling that if I try,
Excuse the interruption. Heart. If you never lost your heart today, go to Miss Fleming's room for a prize. Again, if you started the day with your heart, you never lost it, go for a prize. Also, if you've earned 2 or more hearts today, you also may go to Miss Fleming's room for a prize, 2 or more hearts. Thank you.
okay, good news. I figured out how to, you can see it and it stays. All right, so you guys, we have to subtract $13,118.75 from both sides. So now I have to take 6,926.75 and subtract 13,118.75. And it gives me negative 6,192. Divide by negative 86. And we get 72. So 72, I want to say that was the speakers, right? So why was the speakers?
No idea.
That was just for the sweet.
So we get
Yeah.
72 speakers. But we can plug that in here and it's really easy. 125 minus 72. And it gives us 53 stereos. The good news is there's only 2 word problems on your worksheet,
Shoot.
and they're not as hard as this. They're not, this is a hard one.
I have a hard time like putting it
Okay,
all together.
so you guys, your best bet right now is to start working on it. I do have after school Zoom session at 3 from 3 to 3:30. So you're gonna get help there. Those of you who are in the building right now, I would suggest you get started on your worksheet so you can really, really, really try hard to get some of those, any questions that, answered that you need right now. Okay,